Okay, so something happened to my first take. Apparently, I wasn't recording any sound during the entire thing. So I'm going to show you this in the manner I am talking about. So what I'm going to do is I'm going to be cutting back and forth between the actual paper and this. Just to show you because I don't actually have the printed out paper. So what I will do is I'll cut away. I will show you what I'm talking about on screen, and then I'll show you what I meant on paper. So what we're going to actually start with is this little part right here, and I'm only going to do this first one and this third one. I'm going to skip this middle one because it's just like the first one. So what I did, I'm just going to show you right now, is I used our little two formulas, okay? So our first formula being that if you have log base b, this is not a 6, this is a b, as in boy, okay? If you have a log with a base of b to the x power equals y, it's equivalent to say, in an exponential form, b to the y power equals x. So these mean the same thing. Now, the first one, we realize that the b is 8, because b is in the same spot, the x is 64, and the y is 2. So we have b, the x, and the y. Alright? So all you have to do is take the b, right there, put it right there, where the b would be on the exponent, take to the y, put it for the b is the base, we'd put the y where the exponent's at, right there with the 2, and set it equal to 64. Now one way you can check to see if you're correct is to look at it this way. Is 8 to the second power equal to 64? Well, we know that squared means to take the number and multiply it by itself. So we're going to take 8 squared, or 8 times 8, and it does equal 64. Same idea here. We found the b, it's right there, the x, right there, the y, right there. Alright, and then we just transform b to the y power equals x, so b, which is 6, to the y power negative 3 equals x, 1 over 216. Now why this is a fraction and this one wasn't is you'll notice the y is positive, the y is negative. If it's negative, you're always going to have a fraction. All it means is take the 6, take it to the third power, whatever number you get that, you're just going to put it over 1, so it's going to be 1 over 216. Alright? Now, when we do it vice versa, it's the same idea. All you're doing is you find your b, your y, and your x. Okay, your b, your y, and your x, and you just plug them in the opposite direction. So you put your b, your x, and your y, as stated up here with these two formulas. That means you can go from this to this, or this to this. Okay? So as you guys can see, I started back up. I am right here with this one, and I'm going to do this one over here because it is a root. Let's go back to the root. So now what you can see is that we have 5 to the 1/9 power equals the 9th root of 5. What the 9th root means is just what number to the 9th power would give us 5, and it's usually a small number, but b is still 5, x is still 5 to the 9th root, and then y equals 1/9. So it becomes log base 5, 5 to the 9th, or the 9th root of 5 equals 1/9. Now, this next part, what I'm going to do is I'm actually going to show you how to solve one of each of these, okay? So I'm going to show you how to solve where the x is in the base. I'm going to show you how to solve where the x is at. And I'm going to show you how to solve where the x is the y is at. And then I'm just going to give you the answers to these three so that you can try them out on your own. But once again, I'm going to show you how to do this one, and this one. So let's go to the paper. Alright. Go to the back. Once again, all you're doing to figure out x is transforming it into an exponential function. You find your b, your x, and your y. We transformed it to here. Okay, so now we're trying to figure out what number to the third power equals 27. Well, that's pretty easy if we just take our time. So let's start with 2. 2 to the third power, alright, so 2 to the third power, that's going to give me 8, because that means 2 times 2 times 2. 3 to the third power means 3 times 3 times 3. Well, that does equal 27, so the answer is just 3. This next one's pretty easy because the b and the y are given to us. So we end up with 8 to the third power. And we just got to figure out what is 8 to the third power. Well, that just means 8 times 8 times 8, which ends up with 704. Lastly, you have the ones where the x is where the y is at. This one's trying to make you guess what the exponent is. So you're just going to take b equals 5, x equals 125, y equals x. So that means that 5 to some power gives us 125. Well, let's just start taking 5 to random powers. So 5 to the first power gives us 5. 5 to the second power, that means 5 times 5 gives us 25. Then we have 5 to the third power, so that means 5 times 5 times 5. Well, that does give me 125, so my answer ends up being 3. So, the answers to the next are like so. We get x equals 4, because that means that 4 to the negative third power, because remember, negatives means that we're trying to figure out what's on the bottom, so that means some number to the third power gives me 64. So I figured out 2 cubed, it's 8. 3 cubed is 27. 4 cubed, I should say cubed, gives me 64. So that means x equals 4. The next one is easy. You just take 9 squared, because it just gives you the base is 9, the y is 2, so it'd be 9 squared, gives me 81. And the third one should be negative 3, because we're thinking about 6 to what power gives me 216. Well, it's easy because you take 6 to the first power, which gives you 6, 6 to the second, which is 36, 6 to the third, which is the number we want. So we know that we want 3 as our exponent. But since it's a fraction, we know that it can't be a positive 3, it's got to be negative. Okay, so moving on. Now we're going to combine into one log. Alright? I'm only going to show you some examples of this because I'm just going to show you the rules again and have you guys go from there. So the first one, we know that whenever we're adding, we're actually going to be multiplying the bigger numbers. If we're subtracting, we're actually going to be dividing the bigger numbers. But this all depends on if the bases, these two smaller numbers, are the same. So we have log base 4 of 90 minus log base 4 of 10. Well, they both have 4. So we'll take 90 divided by 10, which gives us 9. Now, we have to put this log base 4 here because that does not change. The only thing that changes is the bigger number. The next problem, plus means multiply, so we're just going to take the 6 and the 4 because both these bases are the same. We're going to take the 6 times the 4, which gives us 24. That gives me log base 7 of 24. Okay. And then I gave you the next 4's answers. The next one will be log base 6 of 3, log base 2 of 6, log base 3 of 42, and log base 11 of 14. Okay. And then you have these funky looking ones. I had these bottom 3 right here. Okay. So what these mean is this. You have b to the log power base b, so if these two numbers are the same, the one number that's not the same is the answer because essentially they cross each other out. So 8, 8, 9. Well, we know that 8 and 8 are the same, so 9 will be the answer. Log base 5 of 5 to the negative 5? Well, the only oddball out here is a negative 5, so it'll be negative 5. Because on this problem, log base b of b, you just get the exponent as the answer. Since the exponent is negative 5, that's our answer. Lastly, is you have 6 log base 6, so these are the same. This 4 will become the answer. The next part. I just gave you the answers to these three, and I'll explain what I did. You'll see a plus minus. That means we're going to multiply then divide on all three of these. So you're going to start with this first one. It says multiply the 9 and the 6, divide by 3. So when we do that, we get 18. So we rewrite the log and the base and just write the bigger number we ended up with. The next one was 4 times 12 divided by 16. So log base 6 of 3. Last one will just be log base 12 of 14. Uses the same method. You're going to multiply these two numbers together, divide by this. So it would be 9 times 6 divided by 3, 4 times 12 divided by 16, 6 times 7 divided by 3. Now the next one, I'm only going to show you how to do one of these because one of these from the first row. So I'm going to show you how to do this one right here, and then just give you the answer to these two since they're almost the same. Then I'm going to do one of these, and then I'll show you the answers to these two, as this essentially is the same thing. First one says log base 9 of 7 times 10 divided by 3. So we know multiply. Multiply means to add. Division means to subtract. So we put a plus and the minus sign. Log base 9, we're going to put log base 9 since we're going to need the same thing all the way through. Last is just put the numbers in order. 7, 7, 10, 10, 3, 3. Okay? The next one's the same thing. Multiply, it told you to multiply these two, but all the bases are the same, so we actually are adding. And then it tells you divided by 7, so we just subtracted 7. Last, same thing. Log base 7 of 14 plus log base 7 of 6 minus log base 7 of 9. Same idea. But when it comes to this next part, so this one right here, is we think of it like this. You have log base 7 of x to the 5th times y to the 6th. So first thing we know is we have multiplication. So we know we're adding. So I'm going to have log base 7 of x to the 5th plus log base 7 of y to the 6th. So I broke those up. Now, whenever you have an exponent, you have to bring it in front of the log. Exponent in front of the log. Okay, so it just becomes 5 log 7 of x plus 6 log 7 of y. Now, since the other ones were just division instead of multiplication, same idea. Alright, this should be your next one, and this should be your answer to the one after that. And then finally, the last part, using your calculator and your brain to find the exact value of logs. And these are pretty easy because all you have to do is either you click log in your calculator and you type in the number. Or some calculators require you to type the number first and then you hit log. But either way, so what we're going to do is if you take the log of 28, you figure out that's 1.4. What that means is since we don't have a number down here, that technically that number is 10, so if we took 10 to the 1.4 power, it would approximately be 28. Same idea with 129. I just round to the nearest tenth. If you take 10 to the 2.1 power, you'll end up getting 129, or approximately 129. And that's the same idea with all three of these. All you had to do is take log, put the number in. Calculator, you're done. But this next part is a little bit different. The reason is I'm asking you not to use a calculator. And that is because all of these numbers are technically divisible by 10. They're easily divisible by 10, so this is the trick we have behind them. So this first one, when we have log of a million, what you're actually doing is you're just counting the zeros. So we count 1, 2, 3, 4, 5, 6. Technically the answer of this is 6. Why? Because if I took 10 to the 6th power, I would get a million. Same thing here, you got 1, 2, 3 zeros. It's in a fraction, so you know it's going to be negative, but 3 zeros, 3. So that means if we took 10 to the negative 3rd power, we'd get 1 over 1,000. Same idea with log of 100. That means if we took 10 squared, or just 10 times 10, we get 100. Last but not least, these two. If you have log of 1 over 10,000, negative because of fraction, 1, 2, 3, 4 zeros, so that's going to be 4. Last. So this would be 10 to the 1st power gives me 10. So we only have 1 0, obviously the answer is 1. The last thing we're going to talk about is this part and then the change of base. Okay, so I'm going to start. So I just did these. So I'm going to start and I'm going to do this problem right here and this problem. The rest should be easy to solve because you just use the same template. Remember, if we don't have a number that's right here, you know your base is automatically 10. So that's all I did was I took the base, set it equal to 10. X is X, Y is 3.4. So you just change this into an exponential function. 10 to the 3.4 power equals X. So you get 2511 equals X. The next one, same idea. B is 10, Y is 2.7, but X this time is this whole value right here, which is just 5X. So what we have to do is you just take 10 to the 2.7 power, okay, because that's what our Y is, equals 5X. Well, we end up getting that is about 501. So 5X equals 501. So what we have to do is take this 5 divided by 5, because we had to get X by itself. Do the same thing with 501. We end up getting X is just 100 and 100.2, and that's it. So I'm going to let you do the rest of those on your own. The last one I'm going to do with you is the change of base. Okay. What the change of base says is if you have a log with a base, alright, that's a different number than this, if these two are different numbers, in order to find the actual answer to this, we have to take log of the bigger number divided by log of the smaller number. So exactly what we're going to do. So I'm going to do this one right here and this one next to it. The rest should be just the exact same, but that's it. Alright. So this first one says 10 log base 7 of 10. So what we do is you take a log, remember that technically means 10, so we're just going to take log base 10, which is not there, of 10, divided by log of 7. So if you do that, if you take that in your calculator and make it look like this, log 10, close parentheses, divided by log 7, close parentheses, you end up with 1.8. Same idea as if we do it with log base 9 of 127. You take a log of the bigger number divided by log of the base, or the smaller number, you end up with the answer like this. Alright? That's how you do all this. Now this is technically 10 minutes shorter, so I feel like I might have rushed through this than I did in the last video, but the last video did not have sound. So please ask me if you have any questions about any of this. And remember, test is going to probably be on the, I would say, the 12th or the 13th. Thank you.